Hi guys, hope you guys are doing well. Okay, it's part three, Sttn121, test one preparation to 25. Okay, let me share my screen. Is it the one? Okay, put this. Okay, I have test one, 2022. Okay, like I said from the previous, I think it was part two and part three. Part two and three. I've mentioned that I only have the question paper that I have, the question paper plus the memorandum. So I'm going to explain how they got those, the formulas they used and how, so they got the answers. Okay, now I have to test one 2021. So 2022 question paper. The first question, let me just try to do it like this. All right, the first question one, they say, given the probability of A as 0.7, the probability of B 0.6, and probability of A and B, which is equal to 0.34, 35. So remember, guys, remember from, I think it was part one, I told you guys on the part one that this symbol, it's the intersection, A and B, the intersection of A and B. If you are given the probability of A and B here, if this is the probability of A and this is probability of B here, if this is probability of B, this is where you're going to find the intersection between this, the intersection between this. So meaning this one will be probability of A and this one will be probability of B. Then this is the intersection. This is going to be the intersection. So mean the probability of A is 0.7, the probability of B 0.6, the intersection is 0.35. Okay, now let's check. We need to test. Which one of the following statement is incorrect? You are looking for the statement that is incorrect. So you're going to test each statement. Let's see. A, they say that probability of complement B is equal to 0.4. Let's prove. The probability of the complement B, I'm going to put the symbol there, which is equal to, remember the formula, 1 minus the probability of B, in this case. The probability of B, which is equal to 1 minus, what is the probability of B? 0.6. Which is equal to 0.4. So statement number one is correct. I'm going to put the C here. Statement number one is correct. So statement number one, if you check, it is correct. Because we got the probability of complement B as, I want to change this one. Let's do it like this. So the complement is, the complement in this one, it's 0.4. We got 0.4. Then B, events A and B are dependent events. How do we prove that events A and B are dependent events? How do we prove that events A and B are dependent? Interesting question. Okay, guys, this is how we prove that events A and B are dependent. I'm gonna write it there. That events A and B are dependent. So if you check probability of A and B, the probability of A and B, this is how we prove it. Ne? This is how we prove that events A and B are dependent events. The probability of A and B in this case already we are given, which is 0.35. We are given the probability of A and B, which is equal to 0.35. So the probability of A and B, for us to prove that they are independent, the probability of A and B must not be equal to probability of A and probability of A multiplied by the probability of B. Okay, this, I mean like this. Okay, this is not, they not equal to probability of A multiplied by probability of B. Okay, probability of A, then multiply by probability Okay, let me just put this probability of B. Okay, let me change this one. Probability of B. Okay, if you check this, let me do it like this. If you check this, for us to prove, guys, that the probability of to prove that A and B are dependent events, it means that the probability of A and B, the intersection, must not be equal to the probability of A multiplied by the probability of B. Now let's test if they are not equal. The probability of A and B is equal to 0.35. So is 0.35 equal to, when we multiply 0.7 multiply by 0.6? What is the answer? Let's see. 0.7 multiply by 0.6. The answer I got 0.42. 0.42. And this side is still 0.35. So you see now that 0.35 is not equal to 0.42 here. Then put the symbol. So this is how you prove that events A and B are dependent events, because they are not equal. What if there was a statement where they say events A and B are independent? It means when they are independent, it means that the probability of A and B must be equal to probability of A multiplied by probability of B. When if here this one it was 0.35, and when we multiply A and B and it's also the 0.35, it means that if A and B are independent. But because now here in this case they are not equal, 0.35 cannot be equal to 0.42. Therefore, events A and B are dependent. So that statement is correct. They are dependent. The statement is correct. Okay, and then what's the other one? Option C, we're dealing with conditional probability. Conditional probability. So with the conditional probability, this is what you do, guys. They say that the probability of A slash B, it means that the probability of A occurring given that B has occurred. So for this one, we're gonna say now the formula. It's the probability of A, and then slash, I want this is one that I want. This one, no, this one, yeah, slash B, which is equal to the probability of A and the intersection B divided by the probability of B. Why are we divided by the probability of B? Because already the probability of B has occurred. So we always divide by the probability that has occurred, which is the probability of B in this case. So that's the reason why we're going to divide by the probability of B in this case. Okay, let me just put this. The probability of B. So if, let's say, for example, it was the probability of B slash A, we're going to divide by A, because it means that the probability of B occurring given that A has occurred. So in this case, we're going to divide by the probability of B here. We divide by this. Now we substitute, because already we have the intersection, which is 0.35 divided by the probability of B, which is 0.6. 0.6. Now 0.35 divided by 0.6. It's 0.58. Wait, on my side, I got 0.58. This is 0.583. 583. Okay, it's fine. But when we say 0.7 multiplied by 0.6, because we can also get the intersection using that. But here in this case, already we are given A and B. You get 0.42. I just want to see something. 0.42 divided by 0.6. And then, okay, it's fine. So it means now, let's see. And then on this one, the answer to get the conditional probability, 0.35 divided by 0.6. And then here, divided by this one, and then you will get 0, I think 0.5 something, 0.58, yeah, something like that. But let's check. Now, when you check this, the A union B, we're going to use the method of non-mutually exclusive event. It's like probability of A, I'm just going to write the formula because the probability, I can just put it somewhere here. It says that the probability of A union B is equal to probability of A plus probability of B minus probability of A and the intersection B. And then now, which is equal to probability of A is 0.7 plus 0.6 minus 0.35, the intersection, which will give you the answer of, let's see, 0.7 plus 0.6 minus 0.35. You will get 0.95. So the answer is correct, 0.95. Okay, 0.95. Right, 0.95, which is this one. Option D is correct. Option D. Option E, events A and B are mutually exclusive. How do you prove that events A and B are mutually exclusive? For us to prove that events A and B are mutually exclusive, it means that the probability of A and the intersection B must be equal to 0. This is how you prove that events A and B are mutually exclusive events. If the probability of A and B is not equal to 0, if it's not equal to 0, then it means that events A and B are not mutually exclusive. So in this case, we can see that the probability of A and B is not equal to 0, is equal to 0.35. You must get exactly 0. So it's equal to 0.35. So this is the incorrect one. So I think on option C is also correct. So I think on option C, um, they made a mistake because it was supposed to be 0.58, 0.5 something. Yeah, on that one. Yeah, I think on that one. So yeah, that's the reason why they said that the answer is E. Okay, hope you guys understand this one. Question 2. Okay, question 2, they say a container contains nine blue. It's what? 9 blue, 7 green, and what? 9 blue, 7 green, and 4 yellow marbles. Suppose I randomly Suppose I randomly suppose I randomly draw 3 marbles from the container. The probability, the probability that exactly 2 yellow marbles are drawn. The probability that 2 yellow marbles are drawn will be what? The probability are drawn is, so guys, remember, on this one, don't forget, on this one, you need to check. The question is, which method are you going to use to get the answer, to get the probability? Is it the one for the combination, or is it the one for the permutations? I think I've explained the difference on part 1. Yeah, I think on part 1, the difference between that on part 1. So guys, this is the method that I'm going to show you. On this one, let's check the total number of the marbles. The total number of the marbles. This is interesting. This is interesting questions. So you need to ask yourself, let's check. They say that I randomly draw 3 marbles from the container. The container, remember, we need to get what we call total marbles. The total, which is equal to 9 plus 7 plus 4, which will give you 20. 9 plus 7 plus 4, which will give you 29 plus 7 plus 4, which will give you 20. The total number of the marbles. Now, if you draw the 3 marbles, Now, remember, if you draw 3 marbles from what? From the container, the probability that exactly two. So when they say the probability of exactly 2, so it means now for us to find, now we need what we call already we have the total. So the question, the minute you can see that the question is based on the combinations. It's based on the combinations. So now we need to what we call, if, for example, we have 9 blue, 7 green, and 4 yellow. Now they tell us the question, the probability that exactly 2 yellow marbles are drawn. The question is based on the 2 yellow marbles are drawn. It means that since you are dealing with the combination, we can say for combination. I've explained the method of using the C on the calculator. For combination 2, which is equal to what? For combination 2 is equal to 6. For combination 2 is equal to 6. Okay. This for combination 2 is for the number of ways to choose exactly 2 yellow marbles for combination 2. Why 2? Because already they told us they put that exactly 2 yellow marbles from 4. I remember we have the number of yellow marbles is 4, and then combination 2, which is 6. Okay, which is 6. Okay, which is 6. Now we come back, we'll be like, okay, since we have 6 as the combination there, for us to find the total number of ways to draw the 3 marbles from 20. I know the question is not tricky, but remember you need to make sure that you understand the question. Remember, now we have this one, the 6, it comes from where? The one for 4 yellow and the combination 2. 4 yellow and 2, this one. 4 yellow and combination 2. Don't forget, they told us if suppose that I randomly draw 3 marbles from the container. The total number of the containers, remember, is 20, and you draw 3. So it's gonna be what? It's gonna be the total number of ways to draw those 3 marbles. It's gonna be 20 combination 3. And when you check that 20 combination 3, and then you will get 1140, 1140, 1140, 1140. Okay, 1140. Okay. Now it means that 1140 is the total number of ways. Okay, is the one that we're going to divide our probability with. This one is the total, the total number of ways. This one, the total number of ways. This is the total, and then this one, the total number of marbles. It's like this one is the total number of outcomes. This one, 1140. Now we're going to check. We'll be like, okay. So now the number for us to get the probability, it's gonna be the probability of exactly 2 yellow marbles. It's gonna be equal to. Need to check. Remember the 6. I get the question. They said the probability that exactly 2 yellow marbles are drawn is equal to what? 6 here, and then multiply by what? 6 multiplied by what? 6 multiplied by. Now, if, guys, you need to be careful of this, né? If we check now, we set it for combination 2. We got 6. Out of 20 marbles, we will be left with what? If we say 20 minus 4 of them, the yellow marbles, will be left with 16. And 16 combination 1. It's like I can just write this question just like this. I can say the first one, 4 combination 2. And then multiply by, can even use the method on the slide, multiply by 16 combination 1. Divide this whole thing by 1140 because that's the total number of outcomes. I believe now you understand how I got the 4 combination 2 multiplied by 16. 4 combination 2, I believe you understand that the reason why it's 16. Remember, the minute I take out the 4 yellow marbles from the container, I'm left with how many marbles? 16, because the child is 20. I'm left with 16. Then combination 1 is like 16, because the reason why it's under combination 1 is because from the 2 yellow marbles, I took 2 from the 4 yellow marbles. Then you see it's gonna be under that side, it's gonna be 1. Unless if it was, let's say for example, it was 3, and I randomly, maybe that exactly 2, I take 2, I'll be left with 1. Or if it was 4 and I take 2, I'll be left with 2. So it's going to be 16 combination 2, something like that. But here in this case, the minute I take 2, 16 combination 1 is the same as 16. So that's the reason why when you punch that on the calculator, you will get the probability as 0,084242, which is option B. You will get the answer of that one, option B. So that you guys now understand, option B. We look at that as another, they said it's option B. Okay, this one here. This one, it's based on the binomial, not the binomial population. It's based on the binomial. So they say, okay, I remember I said when on the, was it part, which part was, I think it was part 2. Part 2, I'm not sure if it was part 2. No, it was part 2. It was part 1. When I was busy explaining the binomial distribution. And I remember I said that but under the binomial distribution, we need the population proportion as pi. Some they call it pi. How do you, the pi will be in the form of a percentage. So meaning in this case, the pi is simple like this one. I think you'll be able to see. The pi will be, okay, let me delete this part so I can write here so that you can all see. The pi will be what? Let's write it like this. Okay, the pi in this case, something like this. The pi will be something like this, yeah. The pi will be equal to 0,10. 0,1, yeah, just say 0,1. 0,1, 0,1, which is 10%. Put it somewhere. 0,1, which is 10%. Now, let's look at the question. They say, suppose that 10% of butterflies, 10%, suppose that 10%, suppose that 10% of butterflies have damaged wings. If a random sample of 10 butterflies is selected, meaning n is equal to 10. N is equal to 10, okay, and then now, okay, selected. What is the probability that more than 4 have damaged wings? The probability of x greater than 4. The probability of x greater than 4. Interesting question. The binomial distribution. Okay, and put this. X is greater than 4, which is equal to. Now, guys, remember, you can also use the method. If they say greater than 4, you know that you're going to start with 5. 5, 6, 7, 8. You make sure that you don't exceed the number of the sample, the random sample. You can take 5, 6, 7, 8, and 9. But that one, it's gonna take you won't be able to because you're gonna find the probability for 5, 6, 7, and then 8, 9, and then you add them together. It's gonna take time. So this is what you do, ne? The best way. 1 minus the probability. If they say greater than, or at least use 1 minus the probability where x is less or equal to 4. And now remember, when it's less or equal to 4, you remember this symbol is for what? At most 4. It's less or equal to 4. And when it's at most 4, remember, it's like you start with the 0 and you end with that number that they've mentioned, which is 4. So it's 1 minus the probability where x is equal to 0 plus the probability where x is equal to 1 plus the probability where x is equal to 2 plus the probability where x is equal to 3 plus the probability where x is equal to 4. Then we're done. I can also put it like this. Then we're done. The formula that we are going to use, I believe is there. I'm just going to open the thing. Where's the formula sheet? I can show you the formula that you guys are going to use. This is the formula that you guys are going to use for the binomial distribution. This is the formula that you are going to use. Okay, this is the formula. Okay, let's do this. There's this formula that I know, but I will advise you to use this one because it's there on the formula sheet. It's n and k. We need the combination n combination k to the power. N combination k multiplied by population proportion to the power k, open bracket 1 minus. So let's substitute. So we'll do step by step. So it's gonna be 1. It's fine. Let me just do it separate. No, it's fine. Let me just 1 into. Let me just do it separate. Let's start with the 1 where x is equal to 0. It's n combination k. What is the value of n? 10 combination k. What is the value of k in this case? It's going to be 0. Agree now? The x. I can also put k there. x0, k1, k2, k3, k4. So it's going to be 0 multiplied by its pi. What is the value of pi? 0, 1. I'm going to put to the power. What is the value of k? 0, 1 to the power what? 0, 1 to the power 0. Here. 0 and here. Okay, let me just put it like this. Let's put the okay, and then open bracket 1 minus like this. 1 minus open bracket 1 minus 1 minus the what is the thing? 1 minus the population proportion. And what is the population proportion in this case? It's 0, 1, 0, 1. And then to the power n minus k. And what is the value of n in this case? What is the value of n? It's 10. 10 minus 0. So we're going to do the same thing with 1, 2, and 3. So I'm just going to write down the final answer. So here, this one, when you substitute this, if you don't know how to enter the combination part on the calculator, go and check part 1 because I have explained it there. I think part 1 or part 2. 10 combination 0 multiplied by 0, 1 to the power 0 into 1 minus 0, 0, or 1 to the power 10 minus 0. And I got 0, I'm just going to write it here. I got 0, 3486. 3486. Okay, which is 4 decimals. I can also write 7, yeah. For this one, 40. And I can just put here, remember, I can just say 4 for 1. The answer that I got. Because remember, you're just going to do the same thing, but where you see 0, you put 1. Where you see 0, you put 1. So we put 1. Then we put 1. And then on my side, I got 0, 0387. 0, 0387. 5 decimals, 874. And then for what? For 2, you do the same thing. Okay, for 2 here, you do the same thing. For 2, on the same formula, on this one, wait, I think I made a mistake on this one. Because you are supposed to be 10 combination 1. So on my side, I made a mistake there. 10 combination 1. Same formula, guys. So here it's gonna be 1, 1, 1. If you move to the one for 2, here 10 combination 2, 2, and there 2. So it's 1. And then the answer I got 0, 0.3874. 0, 0.3874. And then also 2, because 5 decimals. 2, 4, 5. 2, 4, 5, and then 2, 4, 5. And then for 2, where I put 1, I'm gonna remove 1 and put 2. Remove 1 and put 2. Remove 1 and put 2. And then I got 0, 0.1937. 0, 0.1937. And then 1. 5 decimals. For 3. For 3, can just put this here. For 3, I got same formula, 10 combination 3, 3, and 3. And then 3, I'm gonna remove that one. 3, and also 3. I got 0, 0,005,739. 5,739,245. Okay. And then for 4, you see that it's not difficult. For 4, you just need to understand the question. For 4, and then same formula, 10 combination 4, 0, 0.1 to the power 4, 10 minus 4. I'm going to remove that one and put 4. Be for 4, move that one, I put 4. I got 0, 0,0,111, which is 2, 4, and also 6. Okay. 0, 0,0111 and 6, which is 2, 4, and 5. 1, 2, 3, 4, 5. Yeah, 5. Now, I have the probability for 0. I have the probability for 1, 2, 3, 4. According to this, remember. 0, 1, 2, 3, 4. Now, you are going to add all those probabilities for 0. It's going to be 0, 0,34867 plus 0, 38742 plus 0, 0,19393, 0, 0,19371 plus 0, 0,05739 plus 0, 0,1116. And then you will get what's the thing. Let's see something here. See here. Wait, wait. 0, 0,1 to the power k. Okay, which it was, okay, let's see something. Okay, 0, 0,1 and it's 10. Wait. I can substitute this, but this is gonna take time to add all of them. To add all of them, 0 until 4. Yes, that one, because I'm trying to verify this one. Wait. Okay, wait, I wanna see something here. This one, okay, for 1, we got 0, 0,38742, 2, 0, 0,1937, 1, and then for 3, 0, 0,05739, for 4 is equal to 0, 0,0111, and also 6. Okay, and then you add all of them. Okay, let's see, is that, okay, let me go back to the formula. This is the formula. Okay, it's 10 combination the value of k to the power. Let's see something on this one. Okay, on my side, where's the question? Yeah, I got, when I add all this thing, when I add all of them, when I add 0, 0,34867 with 0, 0,38742 and 0, 0,19371, 0, 0,005739 plus 0, 0,1116, I got 0,99835. 0,99385. Okay. And then you'd be like, nah, man, I think it's there on option E. No, no, no. Remember, don't forget 1 minus. 1 minus 0,99385. 1 minus 0,99385. And then I got, um, let's see something. Because I took the, okay, if, okay, let me just do it like this. So it's 1 minus 0,99993, 99, wait. 998. Okay, let me 9983. Yeah, 9983. Let's start 0,34867 because I didn't take all the other decimals, ne? But I will advise you to take all the decimals so that when you add all of them, they give you the accurate answer. So I took 5 digits. 34867 plus 0,38742 plus 0,19371 plus 0,05739 plus 0,01116. It's it's 0,999989835 and 1 minus 0,99835, you will get 0, is equal to 0,0016, which is option C. That's the reason why they say the answer is C. You see, then we're done. That's how you do it. See, interesting. You just need to read the question. Or okay, I'm given the 10%, I'm given N. Now they want the probability of this. This under the binomial experiment or the binomial distribution. That's how you do it. The formula is there on the formula sheet. This is the formula. You do the formula. After, guys, remember, you will always be given this. You will always be given this and also this one. You just do the calculations. Here, you got this one is for 0, this one is for 1, this one is for 2, this one is for 3, this one is for 4. Then you add all of them, then they will give you 0,99835. According to the method that I used, 1 minus 0,99835, you get 0,016. Option C. Hope you guys understand. Okay. Question 4. Suppose X represents the number of the students in STTN121. The question is based on the random variable X. The random variable X. The question. Interesting question. I remember when I was, I think it was part 1, when I was explaining part 1, I said, I think it was part 1, yeah, I said under the random variables, you guys, you remember those? I'm gonna show you guys the formulas, ne? Under this one, check. What is the PX? The probability density function, the PX. When you look at this table, they say the probability distribution of X is as follows. 1, 2, 3, 4, 5. We are given 0,25, 0,33, 0,17, 0,15, 0,10. They say if the mean is equal to 2,52, already they've given you a mean as 2,52, the mean. They want to calculate the variance. Which formula are you going to use? Let's go here. I'm going to change the color here and put red. Guys, this formula, 1 and 2 with red, 1 and 2, we use these two formulas under the random variable X. These two formulas here, these two. So already we are given this mean as 2,52. But for this one, remember on the part 1, I said for you to get the variance, you need this mean. Now let's do it. It says that X minus the mean to the power 2 multiplied by the probability density function. Interesting. Let's substitute here. Okay, I can just say, okay, the variance, which is equal to formula. It says X minus the mean. The first value of x is 1 minus the mean 2.52. Close bracket, I'll put to the power 2. Multiply by the px that correspond with 1, that correspond with this one. It's 0.25, 0.25. We are done with the one for 1. We move to the one for 2. So now it's going to be 2 minus 2.52. Close bracket to the power 2, I'll put to the power 2. Multiply by, with 2, it corresponds with 0.33, 0.33. Then I can just do it like this. And then, okay, now we are done with that one. Okay, but let me just put it here. Yeah. And then now we are done with the one for 2. We move to the one for 3 minus the mean. We're given the mean 2.52. Okay, I will put to the power 2, multiply by the px that correspond with the one for 3. It's 0.17. We are done with the 3. We move to the 4. 4 minus the mean. We're given the mean 2.52. Those bracket, I'll put to the power 2. Multiply by the one that correspond with 4 is 0.15. 0.15. Plus, we're done with the one for the 4. We go to the one for the 5. 5 minus the mean 2.52. I'll put to the power 2. Multiply by the 5 correspond with 0.10. I think I can put it where. Wait. Put it where. Here. Yeah, here. And then I can just, I think it's gonna fit there. And then, yeah, like this. Plus, yeah, like this. 4 and 5. Okay, therefore, when you okay, let me put to the power 2 according to the formula. Guys, can you see that this is easy? And then to the power 2, okay, let me put it like this, to the power 2, and then even this one, to the power 2, and then to the power 2, and even this one to the power 2, and even this one to the power 2. And then this one, okay, let me just do this. Now we're going to enter these values on the calculator to get the variance. Even this one to the power 2. Now the variance is equal to, let's substitute 1 minus 2.52 to the power 2 multiplied by 0.25 plus 2 minus 2.52 squared multiplied by 0.33 plus 3 minus 2.52 squared multiplied by 0.17 plus 4 minus 2.52 to the power squared multiplied by 0.15 plus 5 minus 2.52 squared multiplied by 0.10. And the answer, I think I made a mistake. 2.52, yes. Okay, 1 minus 2.52 squared multiplied by 0.25. Okay, I'm gonna verify something. And then plus 2 minus 2.52 squared multiplied by 0.33. 0.33, okay, plus 3 minus 2.52 squared multiplied by 0.17 plus 4 minus 2.52 squared multiplied by 0.15, okay, plus 5 minus, okay, wait, just do this, 5 minus 2.52 squared multiplied by 0.10, and then the answer 1.6496. 1.6496, which is option A. That's the reason why they say the answer is option A here. That's how you do it. Okay. If they wanted a standard deviation, you're just gonna do a square root of 1.6496, which will give you 1.2844. And it's there. Here it is on option E. Only if they wanted a standard deviation on this question. Okay. Okay, I know after some of you guys have watched this video, you'll be like, okay, how if they wanted a mean, let's say, for example, we are not given a mean of 2,52. Let's prove that it's 2,52. E, Ex is equal to, how do you get the mean? Let's start. 1 correspond with 0,25. So 1 multiplied by 0,25. I'm showing you guys just in case if it happens that on your test one, they give you this table, different values, and they want you to find the mean, EX, expected value. So we move to 1, we are done. We move to the 1 for 2. 2 multiplied, 2 correspond with 0,33. Plus, we are done with 2. We move to the 3. 3 multiplied by 3 correspond with 0,17. We are done. And then now it's, let's put it here. Here. We are done with the 1 for 3. And then 4 multiplied by 4 correspond with 0,15. And then plus 5 correspond with 0,10. Then the answer, let's do it. 1 multiplied by 0,25 plus 2 multiplied by 0,33, 33 plus 3 multiplied by 0,17 plus 4 multiplied by 0,15 plus 5 multiplied by 0,10. It should give you 2,52. 2,52. You see, we're done. So that's how they get the EX, the expected value, the mean. So yeah, that was question 4. Question 3, done. Question 5. Oh, okay. I think this one, because I was looking at the scope that you guys gave me for your test for 2025. The confidence intervals were not there because I have explained 8.1 till 8.15 till the F table. So this one was not part of your scope, according to the scope that you guys gave me. You said you, let me check on the, okay, the person who gave me the scope, we said, okay, I just wanted to know if by any chance, okay, the chi-square, the F table, the T table, and the probability that focus on the combinations, the permutations. I think that's your scope. I think I did that on part 1, part 2. You, even if you go and check on my videos for part 1, part 2, there was no the confidence. It's interesting, the confidence, but on the scope that you guys gave me for the test, this one was not there. Yeah, so I can't do this one. It was not there. Maybe it's going to be on test 2. Yeah. But I'm going to also like do a video on test 2 explaining this one. Confidence. It's interesting. So now according to the scope, it was not there. Let's see this one. Remember this one, the question paper, it has them, but I'm going to explain how they got the answers like this one. I'm going to give you guys the solutions on this one. Okay, now here, a club has 20 members. They are, I think, to select 3 office holders. 3 office, ne? Holders, president, secretary, and treasurer for the elections. They're able to select 3 office holders, president, secretary, and the treasurer for the elections. They always select these office holders by drawing 3 names randomly from the names of all the members. Guys, remember, I think on part 1, I've explained the difference between the permutations and also the combinations. Look at this, ne? How many possible way of arranging? This is the permutations. If you go and check part 1, you'll see what I'm talking about. Arranging 3 names from this 20 member. Interesting. It's gonna be 20 permutation 3. You can just read like this. I think also on part 1 I've explained the permutation on how to enter this value on the calculator, the P, how to get the P on the calculator. You will get 6840. So 20 permutation 20 permutation 3. It's 6,840. So for 1.1, that's the reason why they got 6,840. Now, if they say, now, if the order is not important, what is the total number of arrangements? Guys, remember, the number of the arrangements, it's when we are talking about the combinations. We have to the combinations. What is the total number of arrangements of 3 names drawn from the 20 names? Same thing. 20 combination 3, you are done. You don't have to write it like this, ne? You can just say 20 combination 3, or you just write like this. So 20 on the calculator, I've explained how to get the C there. Combination 3, then you get 1140. Then you are done. So it was done for question 1. It's based on the combination and also the permutations. And also it was there on the multiple choice here. This one here. It was based on the combinations. All right. Okay, then question 2. Oh, interesting. Suppose that 20% of STTN1 students smoke cigarettes. 20%. 7% of them, they smoke cigars. 5% of them, they smoke both cigars and cigarette. Can you see the intersection between this? Let A be the event that they are cigarettes smokers, and B be the event that they are cigar smokers, which is this one, 7%. Then 5% is for both of them, both the cigars and the cigarettes. So the probability of A and B, it's 5%, 0.05. The probability of B, it's 0.07. The probability of A, it's 0.2. Let's check. We'll check this. Ne? Again, now they said the probability of A union complement B. Ne? Union complement B. It's probability of A. The complement is this one. It has the formula of this one. Minus, this is the formula that you use. Ne? If they give you this probability of A union B complement, the complement B, you say the probability of A plus the probability of B complement minus A and B complement. You not leave this one, B complement. So 1, the reason why it's 1 minus, remember there's a complement. I think I've explained it there on part 2. Yeah. 1 minus, what is the probability of B? Okay, guys, let's write it like this so that you can be able to see what I'm talking about. They said, let event A be the event that they are cigarettes smokers. And according to the question, they said 20% of the STN121 students, they smoke cigarette. The probability of A is equal to 0.07. No, 0.20. 0.2. Then for the probability of B, already they said, Uguti, let B be the event that they are cigar smokers. And when you check here on the statement, they said 7% smoke cigars, which is for the B, which is equal to 0.07. Interesting. Now, the probability of A intersect B is equal to, they told us, 5% smoke both cigars and the cigarette, which is 0.05. Interesting question. All right, now we have our probabilities. So I will advise you guys to write it like this so that you can be able to get the answers that you want. And then now A, it's 0, B is gonna be, I gotta according to this. Okay, when you solve this whole thing here, probability of A plus the complement minus this, you will get 1 minus the probability of B plus A and B. You know why they got that? Let's solve this. Let's solve this. Let's put it here. Let's solve it. I want to show you how they got 1 minus probability of B plus B, A and B. You guys be good. I think I had the notes for this. Okay, the probability of A plus the complement B. The complement B, we can write it as 1 minus the probability of B. Okay. Minus A and B. So A and then multiply by 1 minus the probability of B. Just want to show you something. So now probability of A minus probability of A, 0. 1 minus 1, 0. That's the reason why we don't have a value of probability of A, which is 0.2. Now you are left with 1 I want to see something here. 1 minus the product of B multiplied by 1 minus the product of B. I don't know if you guys can be able to see on this one here. Remember, the probability of A and complement B, there's also the intersection. It's fine. This whole thing here, 1 minus the product of B multiplied by 1 minus the product of B. You can also, 1 multiplied by 1, you will get 1. 1 multiplied by 1, you will get 1. So that's the reason why they said 1 minus the probability of B minus probability of B multiplied by the minus the probability of B. It's going to be the positive, the probability of B on that one. Ne? But then now let's look at this to expand this whole thing here. To expand this. If now you check on the part of the probability of A and B, the probability of A and B. Because remember, guys, here, you are given the complement A and B. When you check this, you are given the complement A and B when you look at this. So now to expand this whole thing here, when you check this one, it says 1 multiplied by 1 minus the probability of 1 minus the probability of B plus A and B. A and B. Now, when you look at this one here, we're going to do this. This is the formula, ne? This is the formula that they use, ne? Okay, this is how we do it, ne? It's probability. This one, I want to show you guys something, ne? The probability, I get it's A union complement B. To expand this, it's a probability of A plus B complement minus A and B complement. Okay? Okay, that one. Then the B complement, it's 1 minus probability of B. You understand that? So now it's going to be probability of A plus, here, I'm going to put something like this so that you can all see this block and also this one here. This one. 1 minus the probability of B minus, because according to the formula, 1 minus the probability of B minus A and B. So I can just put it like this and cancel this part so that you guys can see. Just do this. Okay. Okay, this one. Okay. I'm sure you guys should get minus A and B. That one, just leave it like that. Minus A and complement B. Complement B. Complement B. Complement B. Complement B. And I'm like this here. Okay, now A and complement B. This one here. It has its own formula. Guys, I want to show you guys something. It has its own formula. Let's expand that one and see. Probability of the probability of, okay, just do this. The probability of A and B the complement. The formula. Put like this. The formula it's C here. And then you close the bracket, which is equal to, remember, we're expanding this whole formula so that you can see how they got 1 minus probability of B plus A and B, which is equal to the probability of A, the bracket, the probability of A minus the probability of A minus A and B. To expand this, A and B, the probability of A minus the probability of A and B. A and B, like this, A and B. Now it means that here you're gonna get something like what? Now let's put the whole thing together. Let's put this whole thing together. Or can I write it? Can I write it? Let's put this whole thing together. And then when you put this whole thing together, you will get the probability of what? This. So it's gonna be probability of A. Remember now we are expanding the whole thing of A plus from this one plus like this. I want the kill one. 1 minus the probability of B like this, and the kill one, and then plus, don't forget the kill one, 1 minus, remember now I'm following the thing. I'm going to show you what I'm talking about. 1 minus, no, it was not minus. Okay, it's minus the probability, probability of A, and then minus, because according to the formula, probability of A, B, close bracket, the curly bracket. Look at this. Look at this. I'm going to change the thing to this one here. Okay, look at this. The probability of A plus 1 minus the probability of B. According to this, it comes from this one here. Guys, look at this. From this one here. Ne? And then now, probability of A here minus probability of A and B. It comes here from this one. You're going to add them here. Minus. Okay, now to get this, it's going to be A minus probability of A. You will be left with A minus A. It's like 0. It's like 1 minus 1. You will get 0. That's the reason why we don't have the probability of, we don't have the probability of A on this one. And then now you are left with what? With 1 minus B. Can you see that, guys? You are left with 1 minus B. This one is out. This one agrees to A, probability of A minus the probability of A in this one here. Can you say that? A minus A, probability of A minus A. You are left with 1 minus B. So now with 1 minus B, what are you going to do? So it's going to be 1 minus B plus the probability of A and B. The probability of A and B. Because now you're going to, I get the probability of A plus 1 minus the probability of B minus the probability of A and then minus the probability of B. So now it's going to be 1 minus the probability of B here and then plus the probability of what? Of A and B. So that is then why they got this. So 1 minus what is the probability of B? You got 0.07. Showed you here 0.07 plus the intersection is 0.05 and then you will get 0.98 here. I've showed you how they do this. Now here, A union B under the thing, it's 1 minus A union B. This is how you do it. 1 minus under the complement here. A union B. That's the formula. That's the formula. Then A union B. You guys know A union B is the formula for non-mutually exclusive. This formula of probability of A plus probability of B minus the minus the probability of A and B. This is the formula. You just substitute 0.2 is the A, 0.07 B, and then minus 0.05 the intersection, and then you substitute, you'll get 0.78. Then this one is the conditional probability. The probability of B slash A. You remember I said it means that B is occurring given that A has occurred. You're going to divide by probability of A. And then already we are given the intersection as 0.05. A is 0.2. And then you get 0.25. Then you're done. Now, okay, 2.1, 2.2, then 2.3. Now this is since, okay, suppose that A is the subset of B. Okay, and that probability of A is greater than 0 and probability of B is greater than 0, are the events A and B independent? Guys, how do you prove that events A and B independent? I think I've explained it there on what? On part 2. On part 2, I remember I said that if A and B, events A and B are independent, it means that the probability of A and B must be equal to probability of A multiplied by probability of B. So this question is not part of that thing of where 0,07, 0, something. Let's see. Since A is a subset of B, then it means that the probability of A and B must be equal to A. It means that the probability of A and B must be equal to A. Since, agree, on part 1, I have showed you if A is the subset of B, how do you see? I think I have explained that one. So it's equal to probability of A. But in this case, the probability of A and B, already we are told that it must be greater than B. You see, A and B, all of them, the intersection, it must be greater than 0. So if this one is equal to A, and A must be greater than 0, it means that A and B are not independent, because probability of A multiplied by B, it cannot be greater than this one. Can you see that? It is not equal to A and B. So it's not, they are not independent on that one. So yeah, they're not independent. Okay. All right. Now we are on question 3. Consider the following mass function of a discrete random variable x. And then this is you remember on, I think it was part 2 and part 2, I told you guys under the properties, and I told you guys that make sure that you know those properties. State 2 conditions of probability mass function. Remember the first one I said the probability mass function must be between 0 and 1. And when you add all of them, they must give you 1. So when I was saying that when you add all of them, they must give you 1, it's this one here. This one. When you add 0,25 plus 0,33 plus 0,17 plus 0,15 plus 0,10, you will get exactly 1 when you add all of them. So yeah, state 2 conditions. This one, state the conditions. Verify if the probability of x is equal to the x. This one, the probability, the verify that it is a probability mass function. How do you verify? When you check here, you were given the formula. You just use the formula, be like, where x is equal to 0 and also 1. Here it is. They gave you a hint here, 0 and 1. So p, you put 0, 1 minus, where you see p, and then you put the p, because you don't have the value of p, into 1 minus x. X will you put 0 plus p, now you move to 1, 1 minus p into 1 minus 1, which is 0. So you're going to get 1 minus p to the power 0, it's 0. So you're going to get 1 minus p, separate, plus, this one is out, it's 1, it's the same thing, plus p to the power 1. 1 minus p to the 0, it's out, 0. So that's the reason why you're left with p. So 1 minus p plus p, it's like minus p plus p, it's out. Then you are left with 1. That's the reason why you got 1 there for 3.2 to verify. So yeah, question 3 to verify that. And then what was question 2? And then question 1. Okay, you guys understand? Okay, do we still have question 5? Yeah, we still have question 5. Oh, question 5 is not part of the scope for test 1 on the one that you gave me. You can even check part 1, part 2. There was no confidence intervals and the estimators. It was not there. So I'm going to explain only question 4. Question 4. This one is based on the one from Sttn122. I think it was on part 2. For you to check on the one for question 4. So if you check here on this one, they say that the actual volume of soap in 1000 milliliter just follows a normal distribution. Already you're told that it's a normal distribution with a mean of 500 and a variance of 16. How do you get the standard deviation? Square root of 16. It's 4. Square root of 16 is 4. Which formula are you going to use? Z is equal to x. It's x minus the population mean divided by the population standard deviation. So it's something like this. and then divide by the population standard deviation. And remember, to get this population standard deviation, here we are given the variance. You're going to do a square root of 16. You'll get 4. They said, calculate the following probabilities. Remember, it's greater than 1 minus. Don't forget, 1 minus. So it's going to be x is 496 minus 500 divided by 4. And then you will get -1. We say, you go to the table, you go and check the one for the -1. Let's go and check the one for, and remember, -1 is the same as -1,00. Where's -1 under 0, here it is, under 0,00, 0,1587. 0,1587, here it is. Then you say 1 minus 0,1587, then you get 0,8413. You are done. The second one, it's less than, you don't use 1 minus. So it's going to be x as 498 minus 500 divided by 4. Then you get minus 0,5. You just go, and minus 0,5 is the same as minus 0,500. So minus 0,5 under 0,00, which is 0,3085. Then you get this. And then you are done. 2 mark. 2. Get free 4 marks. So yeah, I won't explain question 5 because it's not part of for your scope or the scope that you guys gave me. So yeah, hope you guys understood. Yeah. So I hope now you understood the probabilities, the random variables, the formulas. Go and check out. I'll upload this on my YouTube channel. So it's the other one. So yeah, start the question paper. I think this is 2023. 2023. Okay. Okay, they say now, suppose that, I'm just going to explain this one so that you can also, suppose that probability of A is 0,5, the probability of B is 0,3. Okay, which one of the following statements is incorrect? If you check, if events A and B are mutually exclusive, then A or B is equal to 0,8. If events A and B are mutually exclusive, then A or B is equal to 0,8. So this one, you want to say 0, the formula. Let me write it here. Again, if events A and B are mutually exclusive, this is the formula of B, which is equal to probability of A plus probability of A plus probability of B. Then you add them. 0,5 plus 0,3. 0,5 plus 0,3, you will get 0,8. So statement number 1 is correct. This one is correct. Okay. If events A and B are independent, then A or B is equal to 0,8. Guys, if A or B are independent, the independent event, it goes hand in hand with the non-mutual exclusive. What is the formula? Probability of A or B is equal to probability of A plus the probability of B minus the probability of A and B, or it is simple. Yeah. Okay. B. And then now, when you substitute, you just substitute the values. You'll be like, okay, the probability of A is 0,5 plus the probability of B is 0,3 minus, you multiply probability of A and B, which is 0,5 multiplied by 0,3, and you will get 0,15. 0,15. And then now it's going to be 0,5 plus 0,3 minus 0,15 is 0,65. So that's the reason why this is incorrect, because when they said it's option, it's equal to 0,8. No. This is incorrect. This is incorrect. They say if events A and B are mutually exclusive, then the probability of A/B is equal to 0. So like when you prove that events A and B are mutually exclusive, it's going to be equal to 0, remember. Because A and B will be equal to 0, and everything is going to be 0 there. Then D, if events A and B, so this statement on C is correct. So if events A and B are independent, then A slash B will be equal to 0.5. You know why? The formula of A slash B. What is the formula? Uh, okay, what's the slash B, is equal to probability of A and B divided by probability of B, divided by probability of B. Now this will be equal to, what is the probability of A and B? You got it there. It was 0.15. 0.15 divided by, what is the probability of B? 0.3. So 0.15 divided by 0.3, you will get 0.5. So that's the reason why option D is correct. This one is correct, and this one is correct. The incorrect one is option B. Okay, question 1 done. Question 2. Given that the z is a standard normal variable, the variance of z is always equal to 0. Is that one where they do something like this? Z is normally distributed with the n. Normally distributed, okay, let me just put something like this. Normally distributed, I'm just going to put this with n here as 0, 0, and 1. 0 and 1. 0 and 1. Something like this. So the mean is 0, the variance is 1. That's the reason why they say that it's always equal to 1, not greater than 1. So yeah. Okay, what's the other one? Question 3. The quality insurance engineer of a television manufacturer inspects TV in lots of 100. He selects 5 of the 100 TVs at random and inspects them thoroughly. Assume that 6 of the 100 TVs in the current lot are defective. Find the probability that exactly 2 of the 5 TVs selected by the engineers are defective. Find the probability of that. So you can see that on this one, you can see that on this one, the method that you guys are going to use on this one, the method that you guys are going to use now. Let's check. Let's see. Now here, guys, look at the question and be like, okay, the questions, you might think that this question, it's, some they will think that it is difficult. Look at this. They want you to calculate what? The probability that exactly 2. You need to ask yourself, is this question based on, okay, as from question 4, I believe that you guys can do question 4, because already I did this one from the 2022. You can try this one out. You can try this one, and also you can try question 5. Remember, I told you to know the definition of a random variable. You can also try, even this one is interesting. I've showed you on the 2022 on how to get the EX. You did this one, multiply by this one, multiply by this one, multiply by this one, multiply by this one. And then you will get this. And what's the other one? And then this one also, I think it was on part 1 and part 2. Told you guys to focus to check the binomial distribution, and this the formula, and the formula of the expected. I think I explained this one on part 1. Was it part 1? Part 1, yeah. Also this one. Even question 2. You can see question 2 is the one from Sttn111. Even this one here. Then yeah. Okay, where's the other one? Where's the other one now? So I'm gonna explain the one for, where is it? The one for question 3. Let's check. For question 3, question 3, question 3. Where is it? The question three. The question three on this one. The method is the one that I want. Where is it? Where is it? Is it? Is it on the other one? Okay. So it means that you guys on your side, you guys on your side, you will do what is the thing? You guys on your side will do, you will try to do question two, question three, and also question four on your side, guys. You will try to do that, ne? On your side. You guys will try to do the question three. Where is it? What's the question that I'm talking about? You guys will do this one here. Where is it? Where is it? Where is it? You guys will do this one. Yeah, you guys will do this one. We'll do this question. No, not this one, not question three. From question, I think it's section two. From the B, because I think I've explained that one on the previous question paper that I was doing. You'll do question six and then question seven. Yeah. So can you see that this module is not difficult? But now let's discuss this one before I end the session. So this one, let's check here on this one here. Where is it? Okay, let's see. They say the quality assurance engineer of a television manufacturer inspects TVs in lots of 100. He selects 5 of the 100 TVs at random and inspects them thoroughly. Assume that 6 of the 100 TVs in the current lot are defective. Find the probability that exactly 2 of the 5 TVs selected by the engineer are defective. Exactly 2. So the probability of X that is equal to 2, yes. I forgot to do this. X is exactly 2. Okay, now let's check. Guys, we have the first one, it's 6. Agree they said exactly 2 of the 5 TVs. So it's assume that 6 of the 100 TVs in the current are defective. Find the probability that exactly 2 of the 5, ne? Exactly 2. So now for us to get that probability, it's gonna be the probability is equal to, and just put like this, 6, and then combination, with the capital letter C, combination 2. 6 combination 2 for 6, and the one for the exactly 2. And then multiply by, now out of 100 TVs, out of 100 guys, out of 100 TVs, out of 100, if we minus, remember out of 100, if we minus 6, you'll be left with what? If we say 100 minus 6, you'll be left with 94. So 94 combination, 94 combination what? 94 combination 3. In this case, 94 combination 3. In this case, so 94 combination 3, combination 3. But when you check, remember we have how many? He selects, look at the question, he selects 5 of the 100 TVs at random. And here on this statement, they say find the probability that exactly 2. If exactly 2 of the 5 TVs, now if 5 minus 2 of those TVs, then it means that we will be left with 3. So that's the reason why it's going to be 94 combination 3, divide by everything by what? By the total. And the total is 100 TVs, 100 of them, 100, and then the combination what? The 5 TVs here. That will be the total, the sample space, total number of outcomes. And when you punch this on the calculator, it's 6, and then combination 2 multiplied by 94 combination 3 divided by 100 combination 5. You get 0.0267, which is 0.027. That's option A. So I believe that now you guys stood. You can do this one because this one I've explained this kind of questions, and also this one combination, the random variable on part 1, think it was part 1 and part 2, and then also the expected value, and this one, the binomial distribution and the formula, and this one here on Sttn on I explained this one in the previous question paper. Yeah. So yeah, I hope now you guys are good. All right, please don't forget to make sure that before you practice, make sure that you understand the basics on how to get the probability, the random variables. All right, so that will be the end of part 3, the test 1 preparation.